चलेगा. So write down a question. Right? Write down a question. Uh, galvanometer. There's a pen. A galvanometer of coil resistance 50 ohm and a full scale deflection current of 1 ampere. These are basically three different questions, but I'm just clubbing all of them in one. Has to be converted to an ammeter. इसको थोड़ा सा छोटा करते हैं. This is 1 milliamp. 1 milliamp. 0.5 ampere and ammeter which can measure up to as well as the type of connection with the galvanometer. So you need to mention the type of connection with the galvanometer as well, and you need to find out the resistance value as well. Is this clear? Guys, is the question
Yes,
clear?
sir.
चलिए शुरू हो जाओ. There are two different questions based in this. Start. Yes, guys. First of all, if when you want to make an ammeter, oh, what? Can you see the screen now again?
Yes, sir.
Yes, sir.
So first, when you want to make an ammeter, what should be done to make an ammeter? This is the galvanometer. What shall be done?
A shunt
A
wire.
shunt resistance
A
should be
shunt
Yeah,
connected in
connected
resistance.
parallel.
in
So bus connect karo
parallel
फटाफट.
connection.
So let's connect a shunt resistance in parallel. Let's say the shunt resistance is S. And you don't need to, do this thing. What was the thing? You don't need to memorize the formula. It's not necessary to memorize the formula. You can just derive it. It's easy. So we know this particular thing. If a current IA will be flowing through the ammeter, then IG current should go in galvanometer,
Galvanometer.
and the remaining current should go in the shunt resistance. This is
Shunt
what
resistance.
you should be able to determine whenever you want to convert a galvanometer to ammeter. फिर उसके बाद में what will happen? So simple, since they are connected in parallel, if they are connected in parallel, what will we do? What will we do? We'll equate the
Equal
potential.
potential.
So basically, Ig multiplied by G should be equals to Ia multiplied by sorry, A minus.
Sir, Ovia is asking you to admit her inside the
I already did.
meeting.
I already did. Already did. Ovia is here, no? Ovia, hello.
So she's asking me to tell you. I don't know what happened.
I already accepted her. She is inside the meeting. No? She's there.
Okay, sir.
But she has not connected to audio. She has not connected to her audio because I can see the mute button in front of your name, but I can't see the mute button in front of her. Hello, Ovia, can you hear me?
Yes, so I can hear you. Can you hear me?
I can hear you. So now see this particular thing. Ig into G will be equals to Ia minus Ig into S. So from here you can calculate the value of S. Now see what is the Ia given to you, 10 ampere, right? Ia is given 10 ampere, right?
Yes,
So
sir.
10 minus Ig was given how much? What was Ig? 0.5 ampere. Can you see from here? So 0.5 divided by Ig. Ig is how much? Is this clear? Oh, am I doing the other
So
way?
isn't
Sorry.
9.5, 0.5 and 9.
Hmm. Multiply by what was the resistance? 50. Can you see over here? S will be equals to how much? What will be S equal to? What will be S equals to 0.5 upon 9.5 into 50? So you can calculate. See, it's just like this. Questions will form just like this. No, nothing extra is there. And the main type of questions they come from, the potentiometer part, not this one. These are easy. So note it down. I think the second part also will let me do it.
So we should write it's connected in parallel, right?
We have to write कि S should be connected in parallel with galvanometer. This shunt should be connected in parallel with galvanometer. Yes, tell me. Ovia, your voice is breaking.
Uh, me?
I can hear you, but your voice is breaking.
So you scroll.
Yeah, I can hear you, but your voice is breaking. You can, chat, just text me. So now, when you want to convert it to a voltmeter, then what to do now? Guys, what to do now? We'll connect a. Can you please scroll up? हाँ बिल्कुल बिल्कुल बिल्कुल. Sure. Done over here? हाँ.
I cannot see. Can you scroll up? You have scrolled down, I guess.
So now shall I scroll down?
No, I want to see the starting of the question.
The starting of the question is this only, no? This is the starting of the question. A galvanometer.
You can see answer you've written. Scroll down.
Say I'll read the question for you. A galvanometer of coil resistance 50 ohm and a full scale deflection current of 0.5 ampere has to be converted to an ammeter which can measure up to 10 ampere and a voltmeter which can measure up to 5 volt. These are two different sub questions. Okay. So now the question is find the necessary resistance to be connected as well as the type of connection with the galvanometer. Clear?
Yes, sir. Thank you, sir.
Okay. Why just see why your voice is so breaking? I don't know.
Today my network is really poor. I don't know.
That's fine. Sorry. So I think this is clear. Now, when you want to convert it into voltmeter, what do you need to do?
We should connect to a low resistance.
High resistance in series.
Oh yeah, high resistance is series.
So when you connect it to a high resistance series and when you flow this current Ig, the full scale deflection reading across this should be VV, if you remember.
VV.
है ना?
Yes.
So can you say VV is basically Ig into G plus RH? Yes or no?
Yes, sir.
V equals to IR. So basically, you'll get this equation. So from here, RH will be equals to VV upon Ig minus G. So this will be VV how much? You need to convert it to a 5 volt, right? So 5 divided by what was current 0.5 minus 50. This thing is coming negative, no? So hence this is not possible. This is not possible, okay? Let's make it a little bit more stable. 50 divided by 0. Now this is possible. Guys, can you see in the first case when we did was 5 volt, when we took 5 volt, the answer for RH was coming negative, right?
Yes, sir.
So that is not possible case. So you can't create a 5 volt, scale with the help of this galvanometer. Are you getting my point?
Yes, sir.
So what to do in this case? So I changed the question. I told you to make it 50 volt. 50 volt, so it becomes 50 volt upon 0.5 minus 50. This will be 100 minus 50. And this will be how much?
50.
Answer. Although please remember the galvanometer will not have that much resistance which I have mentioned over here. Okay. I give you some more questions to practice. Let me just find it in my notes. What is the instrument part? Guys, write down the question. So I think these type of questions are pretty much clear. Now heading देखो. Will work upon some new concept that is basically called as the measurement of accuracy. Of a voltmeter. अब देखो guys, mm, suppose there is a resistance of, let's say, some 1000 ohm, 100 ohm, let's say 100 ohm. Hello guys,
Yes, sir.
there is a resistance of, let's say, 100 ohm, and I am flowing a current of, let's say, how much, 2 ampere through this. Okay,
Yes,
if I connect a ideal voltmeter, if this is an ideal voltmeter, then tell me, will any current go through the branch where voltmeter is connected?
No.
So when
no.
all of this 2 ampere current will pass through this 100 ohm and 100 ohm resistance, and it will pass like this simply. Yes or no?
Yes, sir.
Yes,
Can
sir.
anyone tell me what will be the reading in the first case of the voltmeter? What will be the reading in the first case? I into R, whatever the potential difference across these two points is
200.
there, the resistor is there, that is the reading. 100 into 2, which is 200 volt. This is the reading in the first case. Yes or no?
Mm.
So I think
Yes,
first
sir.
case is pretty much clear where there is a ideal voltmeter. But next, let's talk about a real voltmeter. Real voltmeter, will it be having infinite resistance? At least some current
No.
will go through that particular thing.
Yeah.
So if I have a real voltmeter, so suppose this is 100 ohm, and I have a real voltmeter, this voltmeter will have certain resistance of its own. Well, it will be high, but still it will have certain resistance of its own, right?
Yes, sir.
So let us say this voltmeter has some internal resistance R, and let us assume that this 2 ampere current, when it was coming, so a very small amount of current, let's say 0.01 ampere, flows through the voltmeter, and the remaining 1.99 ampere will flow through this 100 ohm and then come back to the battery. Yes or no? Is this clear, guys? So can you see what is exactly happening in the case of a real voltmeter? Guys, can you understand what is exactly happening in the case of a real voltmeter? The voltmeter, even though it is small, but still it is taking some amount of current, right? To operate at least. This is what happens in the case of real voltmeter. Yes or no? Hello?
Yes,
Yes,
sir.
sir.
So in this case, the reading of the voltmeter will be what? It will be 1.99 multiplied by 100. So can you see it will be 199 volts? Yes or no?
Yes, sir.
So in this case, for a real voltmeter, for ideal voltmeter, लिख लो भाई. For an ideal voltmeter, the resistance of the voltmeter, or can I say the resistance of the voltmeter, is infinity. Internal resistance is infinity. So no current flows here. But here in the case of a real voltmeter, a small current, so the reading of voltmeter, can you see the reading of voltmeter is not accurate? Voltmeter is inaccurate because of its internal resistance. Yes or no?
Yes, sir.
So for how much is it accurate? The accuracy will be given by how much? So if someone says ki how much is the voltmeter V2 accurate, if I say this is V1 and this is V2, so the reading of V2 is accurate by how much? Can you see over here? V real upon V ideal multiplied by 100%. Yes or no? So can it will it be like 199 divided by 200 into 100%? Yes or no, guys? Can you see over here? In this case, what is the accuracy? What is the accuracy, guys? 199 upon 200. How much? 99.5%.
99.5.
Answer. So now you understood how to calculate the accuracy of this. Hmm? Yes or no? Understood?
Yes, sir.
Yes, sir.
Shall I give you one question based on accuracy? One more. First, write it down, please. Then I'll be giving you the question. Whenever you're done.
Done, sir.
Chal. Write down next question. अभी तो था पेन का question. There is a 500 ohm resistance and there is a 1000 ohm resistance and there is a voltmeter connect across the 1000 ohm. This whole thing is connected to a 300 volt battery. Okay. Now the question is, in the circuit shown, voltmeter is having a resistance of. Acha, by the way, guys, one more thing. If it is 99.5% accurate, then what is the percentage error? Guys, what is the percentage error? 0.5%, right? Hello?
Yes, sir.
So
Yeah.
if it is 99.5% accurate, then percentage error is this much. So please
And
remember,
facts.
you can give this thing is also percentage error is basically V ideal minus V real upon V ideal into 100%. So this is also one of the things. So voltmeter is having. Shall we done, guys? It may involve a little bit calculation. First of all, what will you do? Guys, how do you find out the percentage error? First, you find out if it would have been an ideal voltmeter, then what would have been the reading? If it would have been an ideal voltmeter, then all of the current would have passed through this 1000 ohm, right?
Yes, sir.
So basically, the net resistance will be R net is 1500 ohm, and I will be equals to 300 upon 1500, which is how much? 1 upon 5, 0.2 ampere. Yes or no? And from here, the potential difference. Can you see the voltmeter was connected across 1000 ohm? Yes or no? So the reading in the first case will be how much? 0.2 multiplied by
2000.
1000. Basically, 200 volts will be the reading in the ideal case. Yes or no?
Yes, sir.
But in the case of a real voltmeter, as given in the question, what will we do? This 500, this 1000, and you have connected a voltmeter having how much resistance?
4000.
4000 ohm. And then this is connected to your 300 volt battery. Yes or no? Ayana.
Yes, sir.
Okay. So now what to do in this case? Voltmeter will basically measure across these 2 points, right? So let's try to find out what is the current first. For current you need net resistance. Net resistance will be equal to, can you see this 4000 and 1000 is in parallel?
Yeah, yes, sir.
So they are in parallel and they are in series with 400 or 500. So I'll say this will be how much? 1 into 4, 4 upon 5. This will become 800 ohm.
800. Yeah, yes, sir.
Shall I do 800 ohm? Please fine. Everyone, is it fine? 1000 into 4000 divided by 5000 is 800. Multiplied by plus 500 ohm. So this is 1300 ohm, right? So R net is basically 1300 ohm. Now the calculation is very bad. So I2 will be equals to 300 upon 1300, which is 3 by 13 ampere, and V2 in the second case. Can you see? V2 in this case is basically I2. अच्छा guys, अभी भी question खत्म नहीं हुआ. This I2 is 3 by 13. It is coming over here. This 3 by 13 will come over here. This 3 by 13 will come over here. Now what will happen? Guys, now what will happen? What will happen now?
It will, some amount will go to the
Yes,
voltmeter, yeah.
split. It will split over here. So can you split the current, please? So let's say a current of I dash goes over here. So let's name it as I dash. So I dash will be equals to 4000 upon 5000 multiplied by 3 by 30. Yes or no? Yes or no, guys?
So I dash is the current through 1000 ohm.
I dash is the current through 1000 ohm. Yes.
Okay.
Basically, this is how much? 4 by 5 or 3 by 13. I am just writing it like this. Is it fine? Now, the last thing is V2 is equals to I dash multiplied by. So when I do this 4 by 5 into 3 by 13 multiplied by 1000, let me check how much.
So how did you get that I dash is 4,000 by 5,000? Like, I didn't understand that.
Beta, if you remember current division, I dash is equals to I R2 upon R1 plus R2 multiplied by total current. The current division trick.
Yes, sir. Okay.
But if they connected in parallel, the R net will be different, right?
What,
It will be
what?
800, right? R net will be 800, right?
Ha, Rnet will be 800. Yes.
So denominator has to be 800, right?
Huh? No. R2 plus R1 when they are in parallel, no? अरे यार, if you remember, मैं वापस लिख देता हूँ. If you remember this trick. If this is R1, this is R2, and then let's say you are sending a current I, and here the current goes with I1, and here the current goes with I2. Then you wrote no I1 is equals to R2 upon R1 plus R2 multiplied by I, and similarly I2 is equals to R1 upon R1 plus R2 into I. ये सब याद है?
Okay, sir.
So this trick we are applying over here. Let me solve it now. What is 13 into 5? 65, right?
Yeah, yes, sir.
So 12,000 divided by 5 is 184.61. 184.61. So this is the final value of your V2, the potential difference across the 1000 ohm resistor. So can you see the real case and the ideal case? They both are different, and can you see the ideal case will always have a lesser reading as compared to your. So this reading is inaccurate. So what is the percentage error? Percentage error will be this 200 minus 184.61 divided by 200 into 100. So this will be minus 15.38 divided by 2. 7.69%. Clear? Is this clear, sir? Is this clear, guys? Is this clear, guys? Done?
Yes, sir.
So these questions are pretty much based on your this thing. Okay. Shall we start with meter bridge now?
Yes, sir.
Yes, sir.
Let's start with the meter bridge. The diagram net पे छापूंगा obviously. Next heading, write down meter. What is the meter bridge? I'll try to draw it. Next, wire drawing. Guys, I think you won't be able to see anything as of now. Screen will be maybe.
Yes, sir.
Copy image. And why isn't it placed? I will do one more. Copy image. let me just post all the page. तो मेरे को necessary pictures हैं मतलब and so guys you will be able to see three different images. Yes or no?
Yes, sir.
Okay. So what are these three images? I'll just tell you. This is the image of an actual experiment. This is the part of the secondary circuit which you want. So now see over here guys very carefully. Can you see there is a meter scale? Can you say there is a meter scale? Yes or no? Guys, can you see a meter scale from here to here?
Yeah, yes, sir.
Okay.
Sir.
Can you see there is a wire over here? Can you see? ये एक छोटा सा दिख रहा है? Can you see this wire? I don't think it will be visible, but there is a wire over here.
So where
This
are you pointing? Okay, yeah.
this wire. यहाँ पे एक wire है. There is a wire over here.
Yes, sir.
A steel wire, just like a guitar का the last छोटा वाला string, E string. Okay.
Mm.
So this is basically your meter bridge wire. यहाँ पे एक wire होता है. It's not visible in this diagram, but there is meter bridge wire. Can you see over here from A to C? Can you see A to C? There is one wire. Yes or no?
Yes, sir.
That wire is basically the meter bridge wire. Can you see over here this wire, this white one? Can you see this white one?
Yeah,
The
yeah,
one which
yes,
is
sir.
going over the scale in the second picture.
Mm.
Basically, this is your meter bridge wire. And now, what is the connection? Can you see from this particular point A to this particular point B? I have connected. Can you see from here to here? I have connected it across an external resistance. Can you see an external resistance? Sorry, they have connected it from the left. Okay. Uh, Flip horizontal. Okay, nice. So guys, can you see over here? They have connected a resistance over here. This is your point A, and this is your point C. So can you see from point A they have connected a resistance over here. So basically this R is this. Okay. Can you see the resistance, guys?
Yes.
Yes, sir.
Ha. Ab, after this particular thing, there is one more, another resistance S which you want to know. So basically, can you see one more resistance S which is over here? ये one more resistance है which we need to find out. Okay.
Mm.
Now what have I done? I have connected this whole thing across a battery. So can you see the external battery as well? An external switch. Can you see this external switch? There should be a resistance over here somewhere. This is the unknown resistance R. Okay, guys, are you able to identify the circuit? Can you see the outer circuit A? They have connected this resistance R. So I think यहाँ पे फिर एक और होना चाहिए. There should be one more resistance which is connected in parallel. They have the secondary circuit which is from point B to the galvanometer to the jockey. पता नहीं कैसा कैसा कनेक्शन है but so I'll explain you over here. So guys, basically what do they do? They have this one resistance and another resistance. They connected, this first resistance, known resistance between R and between these 2 points, and S in between these 2 points. And from point B, they connected one, galvanometer over here, and then they have this jockey. Can you see this pointed thing? This pointed thing is basically this jockey over here. This jockey is just like a pen-like structure. This, can you see this thing? This is the jockey. So basically this jockey is a pen-like structure and you can slide this jockey on this meter bridge wire. Okay. So basically what do? First you have this whole arrangement set up. You have this meter bridge wire. You connect that meter bridge wire across a battery so that some current flows through it. Then across this points A and this point B, you connect this R. Between point B and C, you connect this unknown resistance S. And then you slide the jockey from A point towards C point. At one particular length, you obtain a null deflection point. And that null deflection point is basically the balance length. For those who attended the crash course, this thing, school level electrical instruments, they must be knowing what exactly is the balance length. Okay, so basically, let's start writing about a meter bridge. So, madam, acha, which diagram will you be making? You'll be making this diagram. Please make this diagram as your meter bridge diagram. Okay. Please draw it. So it is an experimental setup used to measure unknown resistance capital S using the principle of balance the condition of each template. Yes, can anyone tell me what was the balance condition of each template?
So you mean P by Q is equal to R by S? That
Yes,
one?
that thing, that thing. Can you see the circuit, guys? If you would draw it like this also, acha, there is a meter scale over here. I'm not drawing the meter scale from A to B. Is it fine? Is it fine, guys?
Yes, sir.
So I'm not drawing a meter scale from A to B. It's a 1 meter wire, obviously. You know? So now basically what do you do in this particular thing? Once this E is closed, current starts flowing in this circuit like from A. This whole thing is A. Can you see? This is A, then this is also A. If this is B, then this is also B, and this is also B. SS. Oh, sorry, this is not B. This is let's name it something else. If this is C, then this is also C. Is this clear? So can you see there is one resistance between A and B, one resistance between B and S. There is one resistance galvanometer between B and J, right? Can you see the length of the wire over here from A to J? If I connect this jockey over here where I obtain null deflection, then can you see this length L where there is null deflection? So always remember this null deflection length is very important on wire AC. Is say L basically AJ in equals to. Okay? Yes or no? So
So
first,
null deflection is where the galvanometer does not
doesn't,
deflect, yeah?
yes, it gives zero reading. Null deflection of
Okay.
galvanometer means zero deflection of galvanometer. So basically,
Yeah,
the
okay.
length at which the galvanometer is not showing any reading or it is showing zero reading is basically called as what? The null deflection.
Null def-
Okay. So
Okay.
basically,
So
whenever
it
you,
means like it's a balanced condition.
yes, balance condition हो जाएगा तो if there is no current which is flowing through this branch B and J, then can you see this resistance of AJ and this R का ratio
Yeah.
will be in ratio with this S and this. Since it's a meter length wire, then if this is L, then this will be 1 minus L. Or if you have taken L in centimeter, then you'll take it 100 minus L. It's up to you. 1 minus L meter or 100 minus L centimeter. Okay? Hello? Hello, guys. So now, if the resistance of the wire per unit length, if the resistance of the wire per unit length is lambda, okay? So, in spite of writing it, I'll just write it lambda ohm per meter. Then, resistance of AJ is equal to L multiplied by lambda, and the resistance of JC will be 100 minus L multiplied by lambda. But please remember, this will be okay, guys. So by balance condition of Wheatstone, what will happen? By balance condition of Wheatstone, R, the unknown resistance. Can you see the R is the unknown? R is the known resistance. So R divided by AJ, the resistance of AJ. So resistance of AJ should be equals to S divided by resistance of AC. Clear? Is it clear, guys? So now this will be
Yes, sir.
Yes, sir.
S will be equals to R JC upon R AJ multiplied by R, and I can write this as 100 minus L into lambda upon L into lambda into R. So can you see lambda and lambda getting cut? So you don't even need to know the resistance of this wire. Okay? So you can just find out the balancing length and hence you can find out the value of unknown resistance using known resistance. Is this clear, guys? So basically this is your little bridge. Simple as that. Okay?
Yes, sir.
Yes, sir.
Well, I'll give you one question. Let's give you some questions on meter bridge directly. So suppose this is 20 ohm. This is R. This is the galvanometer. This is the jockey. This is 40 centimeter. connected a 100 volt battery with a 10 ohm resistance. Okay. Now the question is, in the circuit of a meter bridge, if null deflection is obtained at 40 centimeter length of the wire as shown, find the value of unknown resistance. Direct question है, कर सकते हो? Guys, can you find it out?
Yes, sir.
Find the value of unknown resistance. Do it fast. इसमें ज़्यादा ऐसा I don't think so. You'll need my help, I guess. Satvik is saying 30 ohm is the correct answer.
Yeah, 30 ohms.
So, हो जाएगा question. Direct just 20 by 40 is equals to R by 60, right? It's a meter bridge, right? 20 by 40 is equals to
Yes,
R
sir.
by 60. So from here, R will be equal to 40. And this, can you see this was in centimeter, this was also in centimeter. So there is no difference in either you write it in meter or centimeter. So next question. Sir, in a meter bridge circuit, देखना है ना, लिख रहा हूँ मैं question. In the meter bridge circuit given below, circuit as shown. This is 5 ohm. This is 2 ohm. This wire AB, I couldn't find a wire of length 1 meter, so basically I got a wire of length 75 centimeter and I connected this across. So where will be located with respect to Q? Did you understand the question?
Yes, sir.
Do it fast.
Sir, we not use the
What?
can we not use the formula that S is equal to
No. Now I told you that it works on the principle of Wheatstone bridge. Yes or no?
yeah.
So फिर how will you do this? Exactly the same way. If they are saying कि find the location of B with respect to C. Sorry, आगे
No,
question.
no. I mean, not in this question.
Hmm?
Previous question.
हाँ. Previous question में you can use the formula because it was 100 centimeter wire, no?
Yeah.
Because they didn't mention anything else. They didn't change the length. They just mentioned this. The previous question they have mentioned, but I have not drawn it. Here in this case, I have drawn it. Can you see over here that this length is not 100 centimeters, this is 75.
Yeah, but if we use the method, then we will get it will be
Exactly.
20 by R and 60 by
And you will
40.
get what?
20 by R and 60 by 40.
20 by R and 60 by 4.
40. That's how it works.
नहीं ऐसा तो कुछ नहीं होगा. अच्छा, let's say this distance is x. So this distance will also be how much? 100 minus x. Yes. Oh, sorry. No, sorry, my bad. 75 minus x. Yes or no?
Yes, sir.
So basically, can you see from here 5 upon 75 minus x should be equals to 2 upon x. Khatam. That's it.
Mhm.
समझ में आया what to do? This resistor upon this length should be equals to this resistor upon this. Chalo, note it down. Give me 2 minutes. I'll just come.
can we take it the other way
Yes, guys,
around?
are you done?
Yes,
21, some 21
sir.
point something. It will be 21 point
Yeah,
something.
yes, sir. 21.4.
Okay.
So should we again like minus that 21.4 with 75?
Why? You need to find out the distance from B, right? So say, here I have assumed X as the distance from B. So answer is this
Okay,
one.
sir.
This is your answer.
Okay, sir.
See the variable, no? You assumed it from B. If you would have assumed X from A, then you would have minus. Okay? So easy questions will be found on database. Let's discuss the next and the last instrument, which is basically the potentiometer. First of all, what is a potentiometer? What does it look? I will just copy again from the net.
Measuring unknown resistance.
It is also used for measuring. It has various applications. Depending
Hmm.
upon the application, we use potentiometer. So write down about it. It is an experimental setup used to measure with potential difference across two terminals of a circuit with high accuracy. The voltmeter was not accurate, right? Was voltmeter accurate? Guys, was voltmeter accurate?
No, sir.
No.
So basically, what happens in the case of potentiometer? It doesn't draw any current from the source, which hampers the measurement. So, कोई सा unnecessary current it won't take without drawing any unnecessary current from the source, which hampers the tick. So, first of all, let's see the setup. What exactly is the setup and all? Let me just let it be. I'll just draw it. So, suppose what is a potentiometer? सबसे पहले let's see the apparatus or the setup. Please remember, a potentiometer has two different circuits involved. Potentiometer has two different circuits involved. First is the primary circuit, and second is basically the secondary. Okay. So, what is the primary circuit and what is the secondary circuit? There is this big battery. Can you see this big battery? This big battery is basically called as accumulator battery. And this draw it. This is known as your accumulator battery. Not. It may have whatever resistance it may. You are having some internal resistance of this battery to internal resistance or any resistance connected. है ना? Then these two things are connected to a long wire. I'll draw this wire with a different color. Can you see this wire? This wire AB is called as potentiometer wire. I'll not draw it, write it over here. I'll write it over here. AB is basically a potentiometer. Why? The length of this wire can vary from 1 to 10 meters. It can be long, doesn't matter. Okay? Okay, guys. Hello. So
Yes, sir.
basically,
Yes,
this
sir.
Yes,
AB
sir.
wire is basically a very long straight wire of length generally 1 to 10 meters. One end of this wire is connected to the accumulator battery over here. है ना? This EMF E naught is basically called as the accumulator EMF. ठीक है? It is connected in series with the rheostat. ठीक है? And if you want, you can connect an ammeter as well to measure what is the current in the primary circuit. So let's say I have connected this ammeter A over here. So this ammeter will measure what is the current flowing in the primary circuit. Yes or no? Hello? Is it clear?
Yeah. Yeah.
हाँ. So basically ये वाला अब in the second part, what do we do in the second part? In the second part, what do we do? We have this secondary circuit. So basically a secondary circuit is uh, what can I write? Depending upon the application. Acha, let me add something more in the primary circuit. This thing is connected to this point and this thing is connected to this point. I connect a galvanometer over here and a jockey over here. So basically this is a part of your primary circuit X, Y. What is the secondary circuit depending upon the application for which the potentiometer is used? Which the potentiometer is used, we change the secondary circuit accordingly. Where is the secondary circuit connected? Between points X and Y. Always remember the secondary circuit will be placed in between these X and Y points. Okay? So it can be anything. We'll see exactly each and every application of what is the thing in the potentiometer, the secondary circuit in every different application. So let's write applications of potentiometer. Guys, have you drawn this till here? And please remember, in between these points X and Y, I'll just connect, the secondary circuit depending upon whatever the application may be. So let's start with the applications of potentiometer. First application is to find the EMF of an unknown cell. Okay? To find the EMF of an unknown cell. Please remember this thing, guys. This wire RAB should be having certain resistance. If it won't have resistance, then this circuit will not work. It is not your normal connecting wires. Can you see the black ones? The one which are over here, here, here. These wires, they don't have any resistance. But the wire which is drawn with red, it's having certain resistance. Okay? Then the resistance of that wire I have named it as RAD. Is it fine? So let's see the first application over here, guys. Can you see this particular thing? I'll just copy the whole circuit. Control C and Control V. So this was your primary circuit. In this case, where you need to measure the secondary the EMF of an unknown cell. So what do you do in the secondary circuit? You just take that unknown cell, which may or may not have some internal resistance, doesn't matter. And you see this E is basically the standard cell, and R is basically the EMF of the standard cell. But this is unknown to us. We need to find out this E only, and R is the internal resistance of the standard cell. Internal resistance of standard. This doesn't matter. Whether it's there, whether it's not there, it won't matter. Why? We'll see exactly why. So now see guys, what exactly am I doing? I'll just take this circuit and place it in between X and Y. So can you see? Can you see what exactly did I do? I just put that secondary circuit in between point X and Y. And this is what I'll be keeping on doing, in every application. Is this clear guys? Hello? Now let's
Yes,
say
sir.
initially when the jockey J is not touched on the wire. When jockey J is not touched on the wire, then tell me what will happen. The current will only flow through primary circuit, right?
Yes, sir.
So current will flow only through primary circuit. What will be the current? Can anyone answer me? What will be the current? The current will be basically, what is the EMF across the whole thing? The EMF across the whole thing is because of that accumulator battery, right? So E naught upon what is the total resistance? Can you see this RAB and R
R.
is in C?
R plus RAB.
So R plus RAB. When it is in variables, it looks like a big deal, but when you start doing problems, it will become very much logical. So I is equals to E naught upon R plus RAB. Once you have found out this current, can you find out what is the potential difference across the potentiometer wire AB? All this thing you are doing when you have not connected the jockey. Potentiometer. Potential difference across the potentiometer wire AB. So we want to, what is the potential difference across AB? Will it be equals to I multiplied by RAB?
Yes, sir.
So will it be, can I write it like RAB upon R plus RAB multiplied
Into
by E naught? Yes or no? After
yes, sir.
once we are done with this, we'll calculate something called as potential gradient. Potential gradient across. Please remember the steps. It's a three to four step problem, and once you are done with 3 to 4 steps, then it will be done. First step to calculate current, second step to calculate potential difference, third step is to calculate potential gradient across wire AB, which is the potential difference across AB divided by the
The
length.
length.
Potential gradient is nothing but how the potential difference changes or how the potential drops per unit length of the wire. Is this clear guys? That is what is potential.
Yes, sir.
How the quantity varies, the distance is basically called as gradient. Right? So since potential was dropping with respect to distance, so hence we named it as potential gradient. So VAB upon LAB. So when you will be doing this thing, you will get RAB upon R plus RAB into E naught LAB. Yes or no? Let's name this thing as lambda. Is it fine? Is it fine, guys? Now,
Yes, sir.
this is all these things are done when you have not connected J across that wire. When you have not sent J across the wire AB, right? Now when
Mm.
we touch the jockey on the wire A, on the wire AB, near point A. Now see guys what exactly is happening over here. Now let's say this jockey J is touched near point J. Yes or no? Hello. If I have touched this jockey on this
Yes, sir.
wire AB, so can you see the current I which was coming over here? Now that current will split into how many parts? One part will go over here and I minus I1 will go over here. Yes or no?
Yes, sir.
So can you see
Yes,
here
sir.
now as soon as you touch the jockey, the near point A, the current will start distributing again. So when the current start distributing, what happens? Let's there will be certain current which will be flowing in this branch, right? Yes or no? There will be certain current which will be flowing through this branch, right?
Mm.
So,
Yeah, yeah, yes, sir.
so basically, what you will do when you increase the resistance over here, when you move the jockey over here at this side, hello,
Yes, sir.
can you apply Kirchhoff on this circuit? If you apply Kirchhoff on this circuit, you will come to know this particular thing. Let's say if the resistance of this part is AJ, है ना? I'm going a little bit in detail, not part of the school syllabus, but see the circuit very carefully. This resistance is Raj and the current through it here is I1. Okay, guys. For simplicity purposes, कोई दिक्कत नहीं, I2 नहीं. Now let's take it I1 only, I minus I1. So let's say this is Raj. Can anyone apply Kirchhoff's loop rule over here? What is the current flowing through this branch? It is I
I
minus.
minus
And what
I1.
is the current flowing through this? From A to J, I1 current is flowing. So if I start from walking from A, I'll go from the positive terminal of this battery, hence minus E. Then
I into I
minus
minus
of
I
I
minus I.
minus I1 into small r. And then galvanometer, I'm assuming,
Mm.
doesn't have any resistance over here for simplicity purposes only. And can you see when I go back from here, I'm moving in the opposite direction of current. Plus I1 times of Raj. Yes or no? Equals to.
Mm.
Yes or no? Yes or no, guys? Can we make this
Yes, sir.
equation? If I can make this equation, then control C. No need to write this thing, na? This is just analysis for. So when we touch the jockey here, this part you need to write, which I'm writing over here. No need to write this equation pattern. Near point A, current distributes between the wire and the secondary circuit. Yes or no? Yes or no? We are
Yes,
basically
sir.
we are basically seeing what will happen to the current I minus I1. What will happen to the current I minus I1 when we will increase the value of resistance AJ. Okay, on increasing the value of length of AJ. What is AJ? Length AJ on wire AB, that is on moving towards point B. So from A you are moving towards point B. See what will happen. Okay. So minus of E minus I1 into R1 EB is equal to this. Can I write I1 into RAJ is equals to E minus IR plus I1R? Yes or no? Hello guys. Hello?
Please scroll up.
Please, please write it till here. Till here, but don't finish it over here. No? Don't write this, guys. Don't write this. This is just for analysis purposes only. I'll delete it after once I'll explain. And I'll be taking a little bit more of your time. Chalega, is it fine? You have a class from 4:30, right? Hello?
Yes, sir.
So is it fine if I take 10 minutes of your time?
Yes, fine, sir.
It's
If
okay,
you
sir.
don't want me to go into this much detail, I can just directly make you write the result if you want. I'll just directly write. So, guys, you made this Kirchhoff's equation. Can you see I1 into R is equals to E minus IR plus I1? Can I say I1 will be equals to I1 will be uh, E minus IR upon R E J plus R? Yes or no? Yes or no, guys?
Yes, sir.
So I1 is basically this. I minus I1 will be equals to I minus one. So I into R into plus into R minus E plus I. Am I doing some calculation mistake anywhere? Guys,
So denominator should be Raj minus R1.
R is a minus R, right?
Yeah.
हाँ मैं वही बोल रहा हूँ मैं कहीं कैलकुलेशन मिस्टेक कर रहा हूँ क्या तो बता देना है ना प्लीज इन्फॉर्म मी इफ आई मेक एनी कैलकुलेशन मिस्टेक तो I minus IR plus IR upon R E G plus minus R. Yes? Can I write it like this? Now can you see minus IR plus IR will get cancelled out? This will be I into R E G minus E upon R E G minus R. Yes or no, guys? Will this be your current? Yes or no? Hello?
Yes, sir.
Tell me this particular thing. If you increase the value of length, if suppose AJ was increased, if AJ increases, the length of AJ increases, that implies the resistance AJ increases, yes or no? If you move
Yeah.
from A to B, RAJ will increase. So when RAJ will increase, you take two different values. You take one time, you take RAJ as 1 centimeter, the 1 ohm. Take any example if you want. Take EMF, some EMF will be whatever EMF, E0 or UV. And accordingly try to do, this particular thing. If from this function, over here, you will realize this particular thing. When length of AJ is increasing, RAJ increases, and when RAJ increases, then I minus I1 decreases. I minus I1 was basically the current from the galvanometer. Right? So from this function, you will realize this particular note which I have written over here. Yeah, that is on moving towards the point B on wire AB, the current through the galvanometer decreases. Is this clear? So try to do this analysis at home. Take any take any values and accordingly to the value, see what is the value of I minus I. So once you're done with that, now you know this particular thing. I'm deleting this thing. Try to analyze. It is done using Kirchhoff's voltage law. Is it fine? So at one particular length called as balancing length, I minus I1 becomes equals to 0. That is the current through galvanometer. It was decreasing, right? When you were increasing AJ, this was decreasing. Yes or no? So at one particular length called as balancing length, let's say L, the current through the galvanometer becomes 0, becomes 0, and it shows null deflection. So that length is basically what? That length is basically what? The null deflection length. Okay. So at one particular length, it becomes 0. So at one particular length, can you see? One particular length L. The galvanometer has reading 0. That is, no current is going in this branch. All of the current is going only in the primary circuit. At this point, no current flows through secondary circuit. Only primary circuit के through current is flowing. At this particular time, can you see, if I apply open circuit Kirchhoff from here to here, so the potential across A and J, the potential across A and J, so VA minus VJ should be equals to, if you go from this route or this route, doesn't matter. Can you see, if you apply open circuit Kirchhoff from here, then this battery will come, this resistance will not play any role. Why? Because there is no current. Are you getting my point? I told you, no, the beginning of the question, beginning of the this thing, this resistance will not play any role because we will obtain null deflection length, right? So at this particular instant, the potential difference between points A and J, which is equals to VA minus VJ, becomes equal to the EMF of the standard. Sir, I can't hear you. Hello? Can you hear me now? Hello, hello, hello. Can you hear me now? Guys,
Yes, sir.
the EMF of the standard set. So at this particular null deflection point, VA minus VJ equals to the standard EMF. And please remember, how will you give VA minus VJ? What is the balancing length? L. So L multiplied by, do you remember? The current is still flowing, every current is flowing through the primary circuit, right? And we already calculated the potential per unit length. Can you see lambda? So L into lambda. So can you see how you will find out the value of the unknown EMF? Is this clear, guys? Is this clear?
Yes, sir.
ठीक, चलिए फटाफट note it down. Sir, in the doubt I asked yesterday about providing the electric field,
Hola.
why don't we move the charge around the whole region? Around the whole region means अभी रुक जा, सात्विक, wait for 2 minutes, no, once I can slow down. So it was like we didn't move it throughout the whole region because कभी conservative force होता तो any particular loop, if you would have chosen any loop, then it would have to have 0. Okay, so when you chose that one particular loop where one part of that loop was outside in other region, in the region where was no electric field, वहां पे when you did the whole path thingy, then summation of E dot dl matlab basically integral of E dot dl when you did that. So at one particular length, that pata nahi, CD part I guess, whatever it was. Yeah, over that part, you were getting some value of E dot dl, some value of potential difference. So it was not zero for the whole path. But even if you find any one path where it is zero, where it is not zero, then the field becomes non-conservative. So they have taken that example specifically. Okay. So how can we conclude? Because for every question, for every path, for a conservative field, work done along any path in the conservative field should be zero. Work done in a cyclic path, if you remember. If it's a conservative field, then at least it should not end anywhere. It was non-conservative, that is why it was restricted only to one particular region. But how do we know what loop to choose? Hit and try. Different loops, you choose different loops. Guys, shall I move it down?
Yes.
So you choose different loops. Add one, even if you find one particular loop where it is not happening, then chali, anyways, guys, we'll continue in the next class, and I'll tell you the drawback of this thing as well. है ना? We'll see the loopholes of this potentiometer. But anyways, only two applications are left. One is small, one is big. So in the next class, we'll be done with potentiometer and we'll start with our RC circuits. Okay?
Okay, sir.
Chalo, thank you, people. Bye bye.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you. Bye bye.
Thank you, sir.
Sir, can you explain that heat question
Which question? Heat question?
which you gave for homework? I tried, I couldn't solve it.
Um, one second. Which question, right?
You gave the homework question, right?
ये सब.
हाँ वो दूसरा वाला.
This one or this one?
The circuit you gave, right? That one.
This one?
Yeah, this one.
Kirchhoff लगाया? Did you apply
हाँ.
Kirchhoff?
Yeah. I took current in 5 ohm as I and 10 ohm and 5 ohm as I1.
You took current in. कैसे बोला? Current in.
10 and 5 as I.
This 10 and 5 is I.
No, the 10 and 5 connected to 20,
Oh,
I took it as I.
okay. You
And the
might have
other one
taken
I
it
took
like
as
this.
I1.
You might have taken it like this, है ना?
Yeah.
And then
And then I took through the other 5 ohm as I1.
you took it. This is I1 and this should be I minus I1. Yes.
Yeah.
So there are two equation, two variables. You can choose two loops and solve this particular thing.
But I don't know, I'm not getting an proper answer.
Can you tell me the equations which you made? चल मैं लिख देता हूँ. बाद में check करना. You can make these equations. Minus of
Okay.
10i plus 20 minus 5i. Write these equations. Check later. And then plus 10 is equals to 0. I think यहाँ पे आप तूने mistake करी. I think here. And the second loop is minus 5i1 minus 10 is equals to 0. So I1 will be equals to how much?
2. Minus 2 actually.
I1 will be minus
I
2.
got minus 2.
I1 is basically minus 2 ampere. Yes. What else? What about I from here?
That also will come 2 only.
That is coming 2 only?
Yeah, because it's 15, no? Minus 15 and
Minus
then
15
30.
minus 30, so this is 2. Oh, ho, ho. So no current is passing through this 10-volt battery.
Why
Okay?
no current is passing?
No, sorry. I minus I1, 4 ampere current is flowing through this 10-volt battery.
Yeah, I got that.
Another 4 ampere current through here. So can you see 10 multiplied by 4 is basically 40 watt.
But then through 20 volt, I didn't get 80.
So beta 80, 10 multiplied by, let me check the answer again. I1 in minus 2 ampere. It is 20, right? It is. This is 20 volt, and I was how much? I was how much?
2.
I was how much? 2 ampere. No, so
It was
20
2.
multiplied by, it was 2, 40 volt. It was 40 volt. 40 volt. Okay?
And even power through 10 will change then.
Power through 10 ohm will be how much? 10 ohm.
20.
No, it is 2 square R.
Hmm?
So 40 power through 10 ohm is correct. What is the current through
I
this?
square R, okay, yeah,
The
I
2
square R,
square
fine.
into 10,
Hmm.
right? So this will be 40.
Okay, I got.
So only
Okay,
this
sir.
was wrong. I'll explain. The next class में बता दूंगा आंसर करने को.
Thank you, sir.
ठीक है? Okay.
Thank you.